Hi, in this lecture we will see what are operators in Python. In the previous lecture, in the tokens lecture, we have seen that tokens are of many types. There are 5 types of tokens and one of them is operators. So operators are symbols inside a Python program that are used to perform certain operations on some variables or some constant values, right? So we'll see like what different types of operators are in this video. Let's go. So firstly, what is an operator? An operator is a symbol that tells the interpreter to perform specific operations. For example, arithmetic, comparison, logical, etc. There are different types of operations that you can perform, not just plus minus. Okay, so plus, minus, multiply, divide, these are basic operations. They are called arithmetic operations, but there can be many more such operations. We will see all of them in this lecture. On the values, and these values are called operands. So whenever you are performing an operation, let us say I want to do 3 plus 4 in a programming language, then the plus sign is called the operator, and the operation is done on these 2 values, right? So these values are called operands. So every operation will have some operands and an operator, and this entire thing is called an operation. Okay, and this specific type of operation is an arithmetic operation because we are adding 2 numbers. There can be other type of operations as well. Let us see. Before that, here is an example. If we are writing a is equal to 10 plus 5, here plus is an operator and 10 and 5 are operands. Okay. So these are different types of operators present in Python programming language. There are 7 types of operators possible. First are arithmetic operation. They perform arithmetic or mathematical operations like plus, minus, multiply, divide. I will tell you the difference between single divide and double divide, what the difference is. And then modulo operator and then exponent. Okay. Then we have assignment operators. They are used to assign a value to a particular variable. Okay. So equal to, plus equal to, minus equal to. There are lots of assignment operators. We will see them as well. Then we have comparison operator. They are used to compare 2 expressions or 2 values. Is this particular value greater than this value or greater than equal to, less than equal to, and so on. They typically return a Boolean value, true or false. They will just return like the result of a comparison operation will be either true or false. Because like we are actually comparing like this is greater than equal to this value or not, right? So it's a comparison. Every comparison operation will result in a Boolean output or true or false output. Okay, next we have logical operators. Logical operator combine 2 expressions and basically they are used to combine the result of 2 operations. So for example, and, or, not. This is true and this is true. This is true or this is true. Something like this. Okay, we will see in detail in the coming slides. Next we have bitwise operator. They are very powerful and we will see in detail how bitwise operators work. They actually work on data at binary level. As we all know that computer only at low level understands only binary, right? Every number inside a computer will be stored in their binary representation. So when we say a is equal to 10, actually 10 is not stored anywhere. Like computer doesn't understand the decimal number 10. It only understands the binary of that number. So if you have to operate with the binary of the number, then we use bitwise operators. They are very powerful in competitive programming as well. We will see the beauty of them. Okay. Next we have membership operators, in and not in. They are used to check that a particular element is present in a collection or not. For example, an element is present in a tuple or list or not. So we will see that like what tuple and lists are in data types, and then we will see like how membership operators work. And finally we have identity operator. They just check the equality of 2 values or 2 variables. They actually point to the same variable or not. Right now you won't be able to understand identity and membership. These 2 operators we will discuss after data types and expressions are done. So remaining all the operators we will see in this video. So let's start. So first is we have arithmetic operators. They are used to perform mathematical operations. Whenever you want to perform mathematical operations, you use arithmetic operators. So these are all the arithmetic operators that are supported in Python programming language. First is plus, which means addition. If you want to add 2 values, you can use the plus operator. Very simple example, if you just write 10 plus 5 in Python, and if you run this statement, you will get the output as 15. So 10 plus 5 will be evaluated as 15. And you can actually perform this on constants also and on variables also. Like you can write a is equal to 5, b is equal to 3, and you can write a plus b. And similarly, you can write a plus 7 also, or you can write 7 plus 3 also. So you can have constants, both constants, you can have one constant and one variable, and you can have both variables. That is like all is fine. Okay. It's just that it will, like, if you're using a variable, its value will be placed and then the arithmetic operation will be carried on. Okay. Next is subtraction. If you want to subtract two values, you can use the minus operator. So for example, if you write 10 minus 3, the output will be 7. Just simple plain maths operations are going on, and even the result can be negative as well. Like if you just write 10 minus 20, you will get minus 10 as the answer. So simple maths you can do. Okay. Next is multiplication. Okay, multiplication is done using the star operator. Like in the keyboard, if you press star, that is multiplication. So if you want to multiply two numbers, for example 4 into 3, your output will be 12. Okay. Next is division. So if you just write the forward slash symbol on your keyboard, that is used for division. Okay, because on our keyboard we don't have this division. This symbol is not present, right? And generally in maths we use this for division, but in maths we use this also for division, right? 10 by 3 like this. So this particular symbol is present in keyboard, and this is used for arithmetic division or the division operator. Okay. And specifically this performs the floating point division of two numbers, which means you will get the entire floating point output. So basically if you do 10 by 3, your output will be 3.33333 like this. Okay. It will not just take the integer part, it will take the entire answer. So if you want the entire answer in floating point number, you can use the single forward slash or the division operator. For example, if you just do 10 by 4, the output will be 2.5, right? It is the actual division of 10 by 4. So the output will be 2.5. Now sometimes we don't want the floating point division. We want to divide two integers and we just care about the floor of the answer. Okay. For example, I don't want to actually do 10 by 3 as 3.333. I want 10 by 3 as an integer only 3. I don't care about after the decimal point what is present. So this is called floor, right? Floor of 3.333 in mathematics is 3. If you know about the floor function, this is how the floor function works. So floor of 3.33 is 3. So, and similarly, if you just care about the integer part and note that and you don't care about the decimal part, so basically you want to divide two integers and get the answer in an integer only, then you can use the floor division, which is 2 forward slashes. So if you use 2 forward slashes, it becomes the floor division and it will just give you the integer part of the division. So if you do 10 by 4, it is like the floor division and the output will be just 2. It will not be 2.5. So it will just ignore everything after the decimal point and it will only return an integer as the answer. Okay, next is we have modulus or remainder. So if you have divided any number, you might know this thing. For example, if I divide 10 by 3, what do I do? So I said 3 times 3 is 9 and I get 1 as the remainder. So this while performing this division, this particular value which is left at the end, which you cannot divide any further, is called the remainder of the division, if you know. So in certain mathematical operations, if you want to find the modulus or the remainder, so let us say if I want to find this particular remainder, then you can use the modulus operator or like percentage sign in your keyboard. That is the modulus or the remainder operator. So if you do 10 modulo 3, 10 modulo 3 is the remainder, which is 1. Okay, the output will be 1. So if you observe here, what is happening? 10 by 3 will be what? 10 by 3 will be 3. So it is the quotient. It is the quotient when you perform the division. No, not by 3. Actually, I should write 10 by 3. right? It will give you the value 3 because it is just giving you the like floor division. Floor division is nothing but the quotient when you divide. And if you write 10 modulo 3, you will get the remainder, right? So if you just want the quotient and remainder, you can use the modulo division, and you can just use the floor division and the modulus operator. You will get the quotient and the remainder. And if you want the exact division, like if you want to keep on going and if you want the exact division, you can use the normal division operator. It will give you the exact output like this. Okay, so this is how it works. And next we have exponentiation. If you want to calculate a to the power b, this particular operator is not present in C or C++ or Java. Rest all operators are present in C++ and Java as well. Okay. So actually floor division is also not possible in C++. You can check that out in C++ lectures. But exponentiation is a very important operator that is only present in Python programming language. It will calculate a to the power b really fast. Okay. So if you want to calculate a to the power b, let's say you want to calculate 2 to the power 3, which is 8. So you can just use the exponent. How do you write it? 2 to the power 3 will be written as 2 star star 3. So if you use a single star, it is multiplication. But if you use 2 stars, it is exponentiation. So if you write 2 star star 3, it is actually writing 2 to the power 3. And the value, which is 8, will be returned. So similarly here, the example is 2 to the power 3 and the output will be 8. So these are all the arithmetic operators that are present in Python programming language. Next we have bitwise operators. Okay, so bitwise operators are very powerful operators. We will see they will work on binary of the number. So they are used to perform mathematical operations, specifically bitwise operations. Okay. So bitwise operators perform operations bit by bit on integer values. Bit by bit. Okay, with examples it will be more clear. Each number is converted to its binary representation first. Actually, they are already stored in binary in the computer. So when you are writing a number in a variable, actually it is stored in its binary only, like 10010 like that. So actually performing bitwise operations is not that costly. It's actually very cheap. Actually performing arithmetic operations is much more costlier than performing bitwise operations, because internally when you are adding two numbers, the compiler has to add their binary only. That takes time. Okay, but if when you are doing bitwise operations, that will be much more faster, because like inside the computer, when you learn digital logic, you will know the number is stored in its binary and gates are present, AND gate, OR gate, XOR gate, and using those gates only all the operations take place. And bitwise operations do the exactly same thing. They use those gates to perform the bitwise operations. Okay, so bitwise operations are very fast and they are very effective when you are doing competitive programming. Okay, generally speaking, like in competitive programming, there is a whole set of questions which might be asked that are called bit manipulation problems, and they can be very complex problems. You have to apply a lot of thought process there, and they are all based on bitwise operations. So when we do DSA, there we will discuss like what bitwise manipulation problems are and how to think about them. But this is very basic in Python. There are bitwise operators present, and you can use them to perform bitwise operations. So what happens exactly? Each number is converted to its binary representation, and then the operation is applied on corresponding bits. So firstly, you need to know how to convert a number to binary. To give you a short introduction, like very short trick to do binary. Like let's say the number is 5. How can you convert it to binary? So you just keep dividing the number by 2. So if you divide the number 5 by 2, the answer, like the quotient will be 2 and the remainder will be 1. You keep writing the remainder as well. Then again you divide 2 by 2, you will get 1 and the remainder will be 0. So you keep on doing this until you get a 0 or 1 here. Okay, because after this you cannot divide. Actually, if you divide again by 2, you will get 0 as the quotient and 1 as the remainder, right? So you keep on doing this and then you read it out from bottom to top. So 1 0 1 will be the binary. Similarly, let's do another number. Let us take some other number. Let's take 19. So if you want to actually calculate the binary of 19, how do you do that? Divided by 2. So 2 9s are 18, and then 1 is the remainder. Then again for 9, 2 4s are 8, and then 1 is the remainder. Then 2 2s are 4, 0 is the remainder. Then 2 1s are 2, and 0 is the remainder. Then again 0, and then 1 is the remainder. So if you read it bottom to top, like 1 0 0 1 1. So this will be the binary of 19. Okay, and how do you convert a binary number back to its decimal form? So actually every bit represents a power of 2. For example, in decimal numbers, every bit represents, or every digit represents power of 10. Like how do you represent decimal numbers? Like what is 19? So 9 is actually at 10 to the power 0, and 1 is actually at 10 to the power 1. So 19 is nothing but 10 into 1, 10 into 1 plus 10 to the power 0, which is 1 into 9, which is 19. Right? Same happens with binary as well. Binary numbers, every bit represents power of 2. So this is at 2 to the power 0, 2 to the power 1, and 2 to the power 2. So the final conversion will be 2 to the power 2 into 1 plus 2 to the power 1 into 0 plus 2 to the power 0 into 1. So it is 4 into 1 4 plus 2 into 0 0 plus 1 into 1 1. So it is 5. Similarly here if you do it, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. So if the decimal conversion will be 2 to the power 4 into 1 plus 2 to the power 3 into 0 plus 2 to the power 2 into 0 plus 2 to the power 1 into 1 plus 2 to the power 0 into 1. It will become 2 to the power 4 is 16. So 16 into 1 16 plus 8 into 0 0 plus 4 into 0 0 plus 2 into 1 2 plus 1 into 1 1. So this will become 16 and 2 18 and 1 19. So this is how you can convert a binary number to decimal and a decimal number into binary. Okay, just to give you a short introduction about it. So every number, like if you want to perform bitwise operations on it, firstly you will have to convert it into its binary representation. So 5 is nothing but 101. Okay, you can add as many zeros as you want before that. And 3 is what? It is 11. So convert it into its binary first. 5 is 101 and 3 is 11. Okay. Now after that, now let's look at the operators. So there are like these. Firstly, we are discussing 3 bitwise operators, which are AND, OR, and XOR. So this is the truth table. This is called the truth table of logic gates. So this is the truth table of AND, this is the truth table of OR, and this is the truth table of XOR. So what do we mean by this? So AND, when we talk about AND, its symbol is AND, like this. We have this symbol on our keyboard, right? AND symbol, ampersand. It is called ampersand. So how does it work? Bitwise. Like these operations are always carried on single bits. So 0 and 0 is 0. Actually, AND is true only if, AND is 1 only if both the operands are 1. Because that is how AND works, right, in English language. This and this. So this entire statement will be true only if both the statements are true. And similarly for bits, what will happen? 1 and 1 will be 1. Otherwise, like if you have 0 and 0, it will be 0. 0 and 1 will be 0. And 1 and 0 will also be 0. So same thing happens. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. Only if both are 1, and will be 1. Similarly for OR, if any one of the bits is 1, it will be 1. And if both are 0, in only that case it will be 0. So if both are 0, OR will be 0. If any one of them is 1, so here B is 1, here A is 1, and here both are 1. In all these 3 cases, OR is 1. And how does XOR work? In XOR, if you are performing it on 2 bits, if exactly one of them is 1, then it will be 1. So here both are zeros, so it is 0. Here B is 1 and A is 0, exactly one of them is 1. So and hence it is 1. Similarly here A is 1 and B is 0, so XOR is 1. And here both are 1. We don't want both as 1. We want exactly one of them to be 1. So here in this case it is 0. So this is the truth table of AND, OR, and XOR. Now let us look at these operators. How do they work? We will use the truth table to calculate the results, okay? So first we have two numbers, A is 5 and B is 3. 5 is what? 5 is 101. And 3 is what? 11. So you can add a 0 in the front. And here we are trying to calculate A and B. And this AND is a bitwise operator. AND is a bitwise operator. So when you are performing an AND between two, bit by bit, every bit AND will be done. So 1 and 1 is 1, 0 and 1 is 0, and 0 and 1 is 0. So this is your final output. This is your answer. It will just AND bit by bit, all the bits will be ANDed, and the final answer is it is again in binary. So this is also in binary. So this is actually the binary for 1, right? 001 is the binary for 1 only. How do you convert it into decimal? Again 2 to the power 0, 2 to the power 1, 2 to the power 2. So 2 to the power 0, which is 1 into 1, 1. And then again all the rest are 0. So 1 into 1 is 1. So the binary of 1 is 001. So the answer will be 1 here. This will be 1. Okay. Now coming to OR. Let us perform the OR operation. This pipe, single pipe is the OR operator. Let's perform the bitwise OR operator. So 101, you have to OR with 3. 3 is 011. And you are performing bitwise OR. Okay, this is bitwise OR. So 1 OR 1 is 1, 1 OR 0 is 1, and 1 OR 0 is again 1. Okay, and this is the binary of what? 2 to the power 2, 2 to the power 1, 2 to the power 0. So like 1 into 1, 1, and 2 into 1, 2, and 4 into 1 is 4. 4 plus 2 plus 1, which is 7. So this is the binary of 7. 111 is the binary of 7. So this will become 7. Okay, and then A XOR B. Let us try to calculate XOR of these two numbers. So we have 101 and 011. Let us try to calculate the XOR between these two. 1 XOR 1 is 0. You can check the truth table. 1 XOR 1 is 0. Similarly, 0 XOR 1 is 1 and 1 XOR 0 is 1. So 1 0 0. Again, this is the binary of 6. How? So this is like 2 to the power 2, 2 to the power 1, 2 to the power 0. So 1 into 0 plus 2 into 1 plus 4 into 1. 4 plus 2 is 6. So this is the binary of 6. So the output will be 6. Okay, I hope it makes sense. In the practice exercise, like in the practice lecture, we will have a practice lecture on all the basics of Python. There we will solve more such problems. But I hope you understood like how the bitwise AND, bitwise OR and bitwise XOR work. Okay, it's just based on the truth table. So these are called the bitwise operators. Bitwise AND, bitwise OR and bitwise XOR. Okay. There are more bitwise operators. Next is bitwise NOT. Bitwise NOT. It is used like how to draw it, how to, like the symbol is, in keyboard you have a symbol called tilde. On the top left corner if you see, you have a symbol called tilde. So if you use this, this is actually bitwise NOT. Till now, all the operators that we have seen had two operands. Till now, like think about it, all the arithmetic operators like plus, minus, multiply, divide, floor division, exponent, on modulo, these are arithmetic operators. They all require two operands. You need two operands to add, you need two operands to multiply, you need two operands to subtract. So they are all called binary operators. Binary operators are operators which require two operands. All the arithmetic operators that we have seen were binary. Also bitwise AND, bitwise OR and bitwise XOR, they are also binary operators. They also require two operands. The first unary operator that we are seeing, this is called a unary operator. A unary operator only require a single operand. They can work on a single operand. For example, you can just use tilde and then let's say 7. So this is like bitwise NOT of 7. Bitwise NOT of 7. So how does it work internally? It will just flip every bit of it. So let's say I write NOT of 5. Okay, 5 ka binary kya hai? Like what is the binary of 5? 1 0 1, and then you have lot of zeros in the front, and you can, like if you're just calculating the bitwise NOT of it, every bit will be flipped like this. Okay, and how does the compiler understand this number? This we will see in number representation. Like there is a separate lecture on number representation. You can check digital logic for that. But internally, don't care about it right now. See, in Python programming course, you don't need to worry about how the negative numbers are represented and all. For Python, an easier trick to remember is this thing. Okay, this is the final trick that you need to remember. The unary not or the bitwise not of any number works like this. It is just minus a minus 1. So the formula is bitwise not of a is equal to minus a minus 1. So what does it mean? If you're actually doing the bitwise not of 5, the final answer will be minus 5 minus 1, which is minus 6. So the answer will be minus 6. This is actually the binary of minus 6. How is this conversion made? Don't care about it right now. For you, the common understanding can be that bitwise not of a is minus a minus 1. You can always use this formula. Okay? And similarly, you can actually do it for negative numbers also. So if you're doing, like let's say, like a number a is minus 3. And if you're doing bitwise not of a, then it will be minus of minus 3 minus 1, which means 3 minus 1, which is 2. Okay, so like just use the formula and you are good to go. So bitwise not of a is minus a minus 1. So for 5 the answer will be minus 6. Okay. So these were like some of the bitwise operators. Till now we have seen AND, OR, XOR, and then bitwise not. The next bitwise operators are left shift and right shift. What they do is they shift the binary of a number. So let us say we have a number called like a is 5, and we know that the binary of this number is 0. Like you can write it in 4 bits. Let's say 101. So the binary of 5 is 101. So let us write 101, and you can add some zeros in the front of it. Now let us say I say you have to shift this binary by 2 places. Left shift the binary of 5 by 2 places. This is how we write it. You have to, this is what left shift, right? If you see the arrow is on left, like this is what? Like this is the arrow is on left, right? So it is left shift. You have to left shift the binary of 5 by 2 digits. And whenever you have to use the shift operator, you have to use less than sign 2 times. Because if you use it single time, it is a different operator. We will see that. This is actually a comparison operator. We will see it. So if you use it 2 times, it becomes a bitwise shift operator. So how does it work? It will just shift the binary of this number by 2 digits to the left. So if I shift it by 1 time, like we have to shift it by 2 times. So let us shift it by 1 time first. Then what will happen? This 1 will go here, this 0 will go here, this 1 will go here, this 0 will go here, this 0 will go here, this 0 will go here, and so on. Right? And at the end, a 0 will be added. At the end, a 0 will be added. So everything will be shifted and a 0 is added. So now this is the binary of what? This was 5. If you check, this is the binary of 10. And again, if you again left shift it 2 times. So this is 1 time, and again if you left shift this number, you will get this 0 will go here, this 1 will go here, 0, 1, 0, 0, and so on. And then a 0 will be added. This is the binary of number 20. You can check. So every time when you left shift a number, you are actually multiplying it by 2. It is always correct. Every time when you are left shifting a number by 1, you are actually like multiplying the number by 2, because that is how left shift works. Okay, it is just like adding a 0 at the end, and that will just make the number multiply by 2. So if you are left shifting a number 2 times, you are actually multiplying 2 times. So the answer will be 5 into 2 into 2, because you are left shifting it 2 times. So you have to multiply 2 times. So if you have to left shift, let's say 5 times, then you are actually multiplying 2 5 times, like this. 5 into 2 into 2 into 2 into 2 into 2. So whatever the answer is, 32 into 5, 160. Okay. This is how it works. This is what left shift operator does. It always multiplies by 2. So if you are left shifting it by 1, it means you are multiplying 2 one time. So it is like multiplying by 2. So if the number was 3, it will become 6. And similarly, if you are left shifting it 2 times, you are multiplying 2 times. So 3 into 2 into 2, the answer will be 12. Okay. This is how left shift works. Now coming to right shift. Let us look at right shift now. So let us say we have 5. So 5's by and you have to right shift 5 2 times, let's say. Right shift operator is written as greater than. Single greater than is a different symbol. But if you write greater than 2 times, it is right shifting. Okay, this is an operator. So the binary of 5 is 101. Okay. Now if you right shift it, so every bit will be shifted right by 1 position. So this 1 will go away because see, this is our first bit, this is our second bit, this is our third bit, fourth bit, fifth bit, sixth bit, and so on. So this 1 will go away because you are right shifting, this 1 will go away. Now this 0 will come here, 1, then 0, 0, 0, 0 like this, right? So this 1 actually goes away. So the final answer now, this was 5. If you right shift it by 1 position, the answer now becomes, this is the binary of 2. And again, if you right shift it by 2 times actually, like one more time if you right shift it, you will get 1, 0, 0, 0, 0 like this. So this is binary of 1. Again, if you right shift it, which means right shifting it 3 times, this 1 will also go away, you will get all zeros. So this is 0. If you observe carefully, this is nothing but dividing the number by 2, floor division by 2. You are just dividing the number by 2 again and again. Right? Firstly, you divided 5 by 2, then 2 by 2, then 1 by 2, and so on. It is the floor division by 2 those many times. I hope you are getting it, right? It's not the complete division, it is the floor division. Floor division means you are just taking the quotient. Because we know that 5 by 2 is 2. And then 2 by 2 is 1. Then 1 by 2 is 0. This is the floor division. We are not taking the decimal part, only taking the integer part. So if you have to multiply a number by 2, just left shift it by 1. If you have to divide a number by 2 and only take the integer part, you can right shift it by 1. Okay, so let's say the number is 8. If you right shift it by 1, you are actually dividing it by 2, so the number will become 4. And if you again right shift it by 1, which means if you right shift x 2 times, it means you are dividing it by 2 times. So it is actually dividing it by 4. So 8 by 4 is 2. Okay, so this is how the left shift and the right shift operator works. With some examples. Again, we will solve some more examples when we do the practice questions. These are all the bitwise operators in Python. Okay, next we have assignment operators. So what are assignment operators? They are used to assign values to variables. So in Python, if I want to assign a value to a variable, I can use assignment operator. For example, if I write a is equal to 3, or if I write b is equal to 4 plus 7. So here 4 plus 7 is what? 11. So essentially I want to assign 11 to b. Here I want to assign 3 to a. So if I want to assign a value to a variable, we can use the assignment operators in Python. So the most basic assignment operator is equal to sign. This is the most basic assignment operator. It is just called assignment. So equal to operator is what? It is a symbol in Python. If you write this is the assignment operator. What it does, it assigns the right side to the left side. So generally in the right side you will have a value, in the left side you will have a variable. And also you can have variables in both sides. If you do a equal to b, it will assign the value of b to a. It will assign the value of b to the variable a. Okay. So example, if you write x equal to y. So in all these examples here, we are initially assuming that the value of x was 10 and the value of y was 5. Initially we are assuming that x is 10 and y is 5. So now if I write x equal to y, what will happen? The value of y will be assigned to x, which means now x will become 5. After this line, now x will become 5 and y will become 5, because the value of y is assigned to x. So y will remain as it is, but x will become 5 now. So after this line, what will happen? Result will be x will become 5. Now this is the most basic assignment operator, but we can actually combine the basic assignment operator. This is the basic assignment operator. It just do assignment. right? You can actually combine the basic assignment operator with the binary arithmetic operators and binary bitwise operators. You can actually combine the basic assignment with all the binary arithmetic operators, which means plus, minus, multiply, divide, exponent, everything. And you can also combine it with bitwise operators and you will get more assignment operators. So what happens is, this is also an operator, plus equal to, because plus is an arithmetic operator and equal to is an assignment operator. So plus equal to becomes another assignment operator, and what it does, it adds and assigns. Similarly, you can do it for all the arithmetic operator that we have seen and all the bitwise operators also. So you will get more assignment operators. So let us see how it works. So what do we have here? Plus equal to. Next operator is plus equal to. What it does? Add and assign. So if I write x plus equal to y, again let's look at the same example. Initially x was 10 and y was 5. And if I write x plus equal to y, what will it do? X plus equal to y is equivalent to, it is equivalent to writing x equal to x plus y. So what it will do, it also has two operands, x and y, right? Or you can also write like x plus equal to 3 also. You can have a constant here also. But the point is, this particular operator plus equal to, it will be equivalent to writing x equal to x plus y. So it will first add the value of y to x and then it will assign the value to x itself. So if you want to write this line, there is a shorthand notation of it using this particular assignment operator. This is a special assignment operator in which we are firstly adding the value and then assigning it. Okay, so you can write it like this, and what it will do, x equal to x plus y means what? Initially x was 10 and y was 5, so x plus y is 15. So now at the end of this operation, x will now become 15 because x plus y is 15 and y will remain as it is. So the result will be, after this operation, x will become 15. Okay, so I hope this makes sense. X plus equal to y is just equivalent to x equal to x plus y. Similarly, now you can do it for other arithmetic operator as well. Next is minus equal to. So if you write x minus equal to y, what will happen? X minus equal to y is equivalent of writing x equal to x minus y. Okay, x minus y is what? 10 minus 5 is 5. So after this operation, x will become 5 and y will remain as it is. Y will remain 5. We are not changing y, we are only assigning it x. So x will become 5 and y will remain 5. So after this operation, x will become 5. Now next is multiply and assign. So if I do multiply and assign, it is equivalent of writing x equal to x into y. So x into y is what? 10 into 5 is 50. So after this operation, x will become 50 and y will remain as it is. So the result is x equal to 50. And you can do it with the normal division or floating point division also. So if you do the floating point division, it is equivalent of writing x equal to x divide y. So this is another operator, divide equal to, that will do x equal to x by y. So 10 by 5 is what? 2.0, because it will give you the exact answer in floating point. So x, after this operation, y will remain as it is, x will become 2.0. So the result is x equal to 2.0. Same you can do with the floor division also. If you do it with floor division is by. So you write by equal to. So this is your assignment operator now. So this is equivalent of writing x equal to x by y. Now x by y means what? It is the integer division, which means you will only take the integer part or floor part. So what is 10 by 5 floor part? 2 only. So you will get 2. X will remain 2 and y will remain 5. So after this, the result is x equal to 2. So that is how you can combine the assignment operator with arithmetic operator. Let us see more arithmetic operators now. So the next set of operator is modulus and assign. So again, initially x is 10 and initially y is 5. So if you write x modulo equal to y, that is equivalent of writing x equal to x modulo y. Now what is 10 modulo 5? It is the remainder when 10 is divided by 5. The remainder when 10 is divided by 5 is 0, right? So after this operation, x will become 0 and y will remain as it is. So the result is x equal to 0. Now again, let's say x equal to 10 initially and y equal to 5, and we are using the next operator, which is exponent. So we are combining it with exponent and assign. So if I write x star equal to y, it is equivalent of writing x equal to x to the power y. So what is x to the power y? it is 10 to the power 5. 10 to the power 5 is what? 1000000. So x, after this operation, x will become 1000000. So this value will be assigned to x. Y will remain as it is. Now next is, so these are all assignment operator. Now you can actually combine the assignment operator with the bitwise operators as well, but only the binary bitwise operators, which means OR, AND, XOR, left shift and right shift. You cannot combine it with binary NOT, because that is a unary operator. Okay, so let us do it. So you can combine it with bitwise operator also. So if I do x and equal to y, so this is now my bitwise operator, and this entire thing is actually an assignment operator. So what it will do bitwise and assign. So this is equivalent of writing x equal to x and y. So what is the AND of x and y? So the binary of 10 is what? Binary of 10 is 1010, and binary of 5 is what? 101. Okay, so if I do a bitwise AND of both of them, I will get 0 and 1 is 0, 1 and 0 is 0, 0 and 1 is 0, and 1 and 0 is 0. So I will get the 0 as output. So x will be assigned the value 0 after this operation, and y will remain as it is. So x will become 0 if you do AND equal to. Now similarly, if you do OR equal to, let us see that. So if I do x OR equal to y, it is equivalent of writing x equal to x or y. So binary of x is what? 1010. Binary of y is what? 101. And if you do a bitwise OR in between them, 0 or 1 is 1, 1 or 0 is 1, 1 or 0 is 1, 1 or 0 is 1. So this is the binary of what? 15. This is the binary of 15. So at the end, x will be assigned the value 15. Similarly, if you do XOR, if you perform an XOR, x XOR equal to y, this is equivalent of writing x equal to x XOR y. So if you do XOR between these two, 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 0 is 1. This is again the binary of 15. So x will be assigned the value 15. Okay, this is how you can combine it with bitwise AND, OR and XOR. Now you can combine it with left shift and right shift as well. So if I combine it with left shift and right shift, what will happen? If I combine it with firstly right shift, let's say x right shift equal to y, this is equivalent of writing x equal to x right shift y times. So essentially you have to right shift 10 5 times. So you have to keep on dividing 10 by 2 5 times. So if I divide 10 by 2 one time, I will get 10 by 2, which is 5. And if I divide 10, if I right shift 10 2 times, so let us write it here. You have to right shift 10 5 times. So if you right shift 10 one time, you are dividing it by 2, which means you will get 5. If you right shift 10 2 times, you are dividing it again by 2, which means you will get 2. Now if you right shift 10 3 times, you will divide it again by 2, you will get 1. If you right shift 10 4 times, you are dividing it 1 by 2 again, so you will get 0. And if you right shift 10 5 times, you are again dividing 0 by 2, which means you will get 0. So if you so 10 right shift 5 is what? 0. So 0 will be assigned to x. Now let's see left shift operator as well. So if I write x left shift equal to y, it is equivalent of writing x equal to x left shift y. Okay, so it is like you want to left shift 10 5 times. So it is like you want to multiply 10 by 2 5 times. So the output will be 10 into 2 into 2 into 2 into 2 into 2 5 times. So the output will be 32 into 10, which is 320. So 320 will be assigned to x. So at the end, x will become 320. Again, in all these operations, y will remain 5. Y is not changing. Only the value of x will change after this operation. And remember that all these assignment operator, how are we writing them? Firstly, we are writing the combination, which means writing and then equal to. It is not equal to and. This is wrong. This is correct. So firstly the combination and then the assignment. This is how you write them. So these are all the assignment operators. We had one basic assignment, and then we actually can combine the assignment operator with all the arithmetic operators and the bitwise operators as well. They just have to be binary. Okay, so they are all assignment operators in Python. Next we have comparison operators. So comparison operators are used to compare two values. If you want to compare two values, are they equal, are they not equal, if A is greater than B, if A is greater than equal to B, if A is less than B, or if A is less than equal to B. So these are all the comparison operators in Python. These expressions return a Boolean result. They will always return a Boolean result. They will always give you at the end true or false, because you are comparing two values. So you are saying A is equal to B or not. So you will get the answer as true or false. So all the comparison operators will always give you a Boolean output which is true or false. Okay, and these operators are also called relational operators. Comparison operators are also called relational operators, and they are used to compare two values or two operands. So all of them are binary operators. They will require two operands. First is equal to, which means if you want to compare two numbers are equal or not, so you can use the equal to sign two times, equal to equal to. This is the comparison operator. Remember the fact that single time equal to is the assignment operator, but if you write equal to two times, it is the comparison operator. Okay, so be mindful what you want to do. If you want to assign values, you use this. If you want to compare values, you use this. So if I write 5 equal to 5, so 5 and 5 are equal, the answer will be true. If I write 5 not equal to if I write 5 equal to 6, then the output will be false. Okay, and again these can be used on variables as well. I can write A equal to B. So here we will check the value of A and B are equal or not. Okay, on variables or constants also you can write like this: 5 equal to A, or you can write A equal to 5, anything like that. Okay, so both the operands can be constants, variables, anything. So first one is equal to, second one is not equal to. It is just the opposite of equal to. So it will return true if the values are not equal. If the values are equal, it will return false. So it is just the opposite of equal to, that is not equal to. So here the symbol is not equal to, which means exclamation mark and then equal to sign. So if I write 5 not equal to 3, 5 and 3 are not equal, so I will get the result as true. But if I write 5 not equal to 5, they are equal, so I will get a false. Okay, so this is how it works. 5 not equal to 3 is true. Next we have greater than. Okay, so we have a greater than symbol in our keyboard. If I write 5 greater than 3, is 5 greater than 3? 5 is greater than 3. Or if I write 7 is greater than 3, 7 is also greater than 3, then I will get true. But if I write 3 is greater than 5, then I will get false, because 3 is not greater than false. Or even if I write 5 is greater than 5, 5 is not greater than 5, 5 is equal to 5. So here also I will get false, but here I will get true. This is how the greater than symbol works. Simple, right? Next we have less than. So simple, like just the opposite of greater than. It will just check if the number is lesser than that value. So if I write 3 is less than 5, I will get true, because 3 is less than 5. If I write 5 is less than 3, I will get false, because 5 is not less than 3. If I write 3 is less than 3, 3 and 3 are equal, 3 is not less than 3, so I will again get false. So 4 is less than 2 will give you what? 4 is not less than 2, 4 is actually greater than 2, so this will give you false. Now next is greater than equal to and less than equal to. So in mathematics, we write the greater than equal to symbol like this. Greater than equal to, right? I can write like this: 3 greater than equal to 1. But this symbol is not present on the keyboard. So what do? We write it like this: greater than equal to. Again remember, greater than equal to, not like this. This is wrong. Okay. So this is greater than equal to. So if I write 5 is greater than equal to 3, I will get true, because 5 is greater than or equal to 3. Or if I write 5 is greater than equal to 5, again I will get true, because 5 is greater than or equal to 5, because it is equal to 5. But if I write 3 is greater than equal to 5, so 3 is not greater than or equal to 5, so I will get false. Okay, so here is an example. If I write 6 is greater than equal to 6, 6 is equal to 6, so I will get true. Next is less than equal to. Very simple again. So if I write 3 is less than equal to 5, I will get true, because 3 is less than equal to 5. If I write 3 is less than equal to 3, I will again get true. But if I write 5 is less than equal to 3, I will get false, because 5 is not less than or equal to 3. Very simple operators, right? Equal to, not equal to, greater than, less than, greater than equal to, less than equal to. So if you write 3 less than equal to 1, 3 is not less than equal to 1, 3 is actually greater than 1. So we will get false. So it will always give you true or false as output. Okay, so these are all the comparison operators or the relational operators in Python. Okay, next we have logical operators. So logical operators are used to combine conditional statements. So if you have to combine two, like one or more expressions, then you can use logical operators. So like let's say here we have written x greater than 5 and x less than 20. So if both the statements are true, then you will get true, like that. So and, or not. There are three logical operators in Python. They are very simple. There are three operators, and, or and not, and we simply write them in English language, and, or and not. Okay, so these are operators. And remember, like this is especially in Python. In Python we write them in like this, and or not. In C++ we write them differently. In C++ we write it like this, but in Python we don't write it like this. We write it like A and D and. Okay, so the operator itself is and, or and not. So what does and do? So again it will contain two operands. So generally speaking, you will have one expression here, then and then another expression here. So if this evaluates to true and this also evaluates to true, then only you will get the final answer as true. If any one of them is false, the final output will be false only. Okay, so our operator AND will give you true if both the operands are true, if both are true. So if you write like this, if you write true and true, simply run this statement, you will get true. If you run true and false, you will get false. If you run false and true, you will get false. If you run false and false, you will get false. Okay, so like this is like that. And second is or gives you true if at least one of the statements is true. If any one of the statements is true, you will get the answer as true if you are using or. So if or will give you false only if both are false. Only in this case you will get false. In all other cases you will get true as the answer. And next is not. Not inverts the Boolean value. So if you write not true, it will give you false. If you write not false, it will give you true. Okay, so not will invert. So these two are binary operator because they require two operands, and this is a unary operator because it requires only one operand. So not is a unary operator and or are binary operators. Let us see an example. So here the value of x was 10. The value of x is 10, and we are saying x is greater than 5 and x is less than 20. So is x greater than 5? 10 is greater than 5. So this is true. This is true. And we have x is less than 20. Is 10 less than 20? 10 is less than 20. So this is also true. And we know that true and true is what? True. So we will get the output as true. If any one of the statement had been false, so if we have written x less than 5 here, then x less than 5 would have been false. Even though this is true, false and true would become false. But if both the statements are true, you will get true. Now next is print not of x less than 5. So is 10 less than 5? 10 is not less than 5. So this statement is false. This statement is false. Right? X less than 5 is false. And if you write not of false becomes true. So not of false will become true. Output will be true. This is how not works. And here we have or. So if x is 10, if here we have said 10 is less than 3. Is 10 less than 3? 10 is greater than 3. So this is false. This is false. And we have or 7 is less than 6. Is 7 less than 6? 7 is not less than 6. So this is also false. And we know that false or false is what? False. If one of the statement had been true, the output would have been true. So if I write 7 is greater than 6 here, even though this is false, 7 is greater than 6 would have become true, then the final output would have been true. So this is how you can combine multiple comparison operators or multiple statements which evaluate to true or false, and you can get the output as true or false. Again, they also return output as true or false only. Okay, in some special cases they output actually some other data types as well. So that we will see in next lecture. Like in the coming lectures we will see data types lecture, like what. But generally speaking, if the expressions evaluate to true or false, their output will also be true or false, which is Boolean. Okay, so if you want to combine multiple conditional statements, you can use the logical operators. So far what all operators we have seen? If we do a summary, we have seen the arithmetic operators in Python, the mathematical operations. We have seen the assignment operators, which means the normal assignment and assignment combined with arithmetic and bitwise operators. We have seen comparison operators in Python. We have seen the logical operators in Python. We have seen bitwise operators in Python. We have not seen membership operators and identity operators. These two operators we will see after the data type lecture. We will see two lectures first, data types and the variables lecture. So only after these two lectures we will be able to understand identity operator and membership operator. So at the end of these lectures we will cover the membership operator and identity operator as well, because you need some more understanding of data types and variables, then only we will be able to see identity operator and membership operator, but we will cover them in the next set of lectures. Okay, so these are all operators in Python. Now we will see a demo on operators. We will try to see in a demo like how all these operators actually work in hands-on. Okay, now let's see a demo on operators in Python. In this lecture we have seen arithmetic operators, bitwise operators, assignment operator, comparison operator and logical operators. Now we will see hands-on like how to use these operators. Firstly, in this collab I have created some text boxes. It's very simple to create a text box in a collab. You just need to create this plus text button and it will create a text cell. So this is not like a normal code cell in which you can write code and run code. This is just text cell. If you write any piece of text here and hit enter, shift enter, it will just display this text. And in this text cell you can enter markdown as well. Markdown means you can enter heading, subheading and so on. So if I write hash, it will give me a heading, double hash give me a subheading and so on. So the benefit of subheading is when you go to index you will see all the headings and subheadings here and you can jump to any one of them. Okay, so that is how you can use the text boxes. And now let's start with first operator, which is arithmetic operator that we have seen in lectures. So the arithmetic operators that we have seen are addition, subtraction, multiplication, division, floor division, remainder and exponent. So let's start writing some code. If you want to add two numbers, we have to use the plus operator that we know. If I do 10 plus 5, it will just add 10 and 5. Now how is the output printed? Okay, so like we will see in the coming lectures how to input and output in Python, how to take input and how to print something, but even without using print the output is printed here. So that is the magic of collab. In collabs generally what happen, when you hit shift enter in any cell, it will by default always display the output of the last line that you executed, only the last line. So if you write 10 plus 5 and let's say okay, if I write one more statement, let's say 10 plus 3, then it will only display the output of the last line. If you have to print the output of all of them, you have to use the print statement that we will see in the coming lectures. Okay, but for now let's use this utility and let's write only one statement in a cell and it will automatically display the output. So if I do 10 plus 3, it will give me 13, and similarly if I do 10 minus 3, it will give me 7. When I run this piece of cell, it will give me 7. This is subtraction. Next is multiplication. So 10 into 3 is 30. Now next is division. So normal division. If you just use a single slash, it will perform normal division and it will give you the output in decimal places. Okay, the exact output 3.3333, right, like that. Now if you want to do floor division, if you just want to take the integer part, you have to use double forward slash, which is 10 by 3. This will just give you the integer part, which is 3. And if you want the remainder, like remainder when 10 is divided by 3, so the remainder is 1. So you can use the modulo operator for that, 10 modulo 3, and this will give you the modulo, which is 1. So when 10 is divided by 3, the remainder is 1. And the last arithmetic operator is exponent. So if you want to do a to the power b, you can use 2 stars to do that. So if you do 10 to the power 3, it will give you 10 to the power 3, which is 1000. So 1000 will be the output. Okay, so these are all the arithmetic operators and this is how you can use them. Now next is bitwise operator. So they work bit by bit on the binary of the data. So we have already seen that. Now if I do 10 and 3, the output is 2. So the output of 10 and 3 is 2. Now let us see how. Okay, so the binary of 10 is what? The binary of 10 is 2 5s are 10 and the remainder is 0, and then 2 2s are 4, remainder is 1, then 2 1s are 2, remainder is 0, and then 0 and remainder is 1. And if you look at backwards, you will get the binary of 10. So the binary of 10 is 1 0 1 0. Okay, and similarly the binary of 3 is what? The binary of 3 is very simple, 2 1s are 2, remainder is 1, and then 0 1, and if you look at backwards, the binary is 1 1. So 10 and 3 means you take the binary of 10 and you take the binary of 3, and let's append zeros here, and you do bit by bit and. So 0 and 1 is 0, 1 and 1 is 1, 0 and 0 is 0, and 1 and 0 is 0. So this is what the output is. So 1 0 is the binary of 2. 1 0 is the binary of 2. We already know how to convert binary to decimal, and hence the output becomes 2. Now similarly, if you perform OR between these two, let us do that. So if you perform OR between these two, so 0 or 1 is 1, 1 or 1 is 1, 0 or 0 is 0, and 1 or 1 is 1. So 1 0 1 1, this is the binary of 2 to the power 0, which is 1 to the power 1 2 4 8. So you will get 8 plus 2 plus 1, which is 11. So if you take OR of these two, you will get the answer as 11. And similarly, let's take XOR as well. So if you take the XOR, 1 XOR 1 is 1, 1 XOR 1 is 0, 0 XOR 0 is 0, and 1 XOR 0 is 1. And this is the binary of 9. So the OR will come out as 11 and XOR will come out as 9. So now let's see in code this happens or not. So if I do 10 or 3, the output is 11, which is expected, and 10 XOR 3, the output is 9, which was also expected. Okay, so these are bitwise operators, binary operators. Now if you do bitwise not of 10, bitwise not of 10, I already told you bitwise not is very simple. It is minus a minus 1. So bitwise not of 10 will be minus 10 minus 1, which is minus 11. Okay, and if you do 10 left shift 3 times, so let us see the output of this. So I want to execute 10 left shift 3 times and 10 right shift 3 times. Okay, so let us see again what should be the output by using bitwise operators. So the binary of 10 was 8 and 2 10. Okay, now if I left shift it one time, it will become left shift means everything will be shifted by 1, or you are multiplying it by 2 3 times. Okay, so left shifting it by one time, you will get 1 0 1 0, and 0 will be appended at the end. So this is one time, and the second time you left shift, again a 0 will be appended at the end, and the third time when you left shift, again a 0 will be appended at the end. Essentially you are multiplying it by 2 and then multiplying it by 2 and then multiplying it by 2. So this has to be the binary of 8 into 10, which is 80. So the output should be 80. And similarly when you are right shifting, so 1 0 1 0, when you right shift it by 1, so this 0 will go away, it will become 1 0 1, which is essentially dividing it by 2. Then again you divide it by 2, floor division. Okay, then you will get 1 0. Then again if you right shift it by one more place, you will just get 1, which is again dividing it by 2. So essentially you are dividing 10 by 8 and taking the integer part, which is 1. So if you left shift 10 3 times, you will get 80, and if you right shift 10 3 times, you will get 1. So again using the code, let's see this happens or not. So if I left shift 10 3 times, output is 80, and right shift, the output is 1. Okay, so these are the bitwise operators. Now let us look at assignment operators. So first is very simple. You want to assign a value to a variable, you can do that. So if I assign the value of 3 to a variable a, you can do that. This is just assigning a value to a variable. Okay, what variables are, we will see. So like now if I print a, if I just write a, I told you like by default Colab will always display the output of the last line. The output of the last line is the value of a, which is 3. So 3 is displayed here. So the value 3 is now residing in the variable a. Okay, now let us do something else. Now we can do this add and assign, subtract and assign, and so on. So let us use the same example which we already did. We did all the assignment of like arithmetic operators on 10 and 3. So let us use 10 and 3 only. So a is 10. Now if I do a plus equal to 3, which means now the value of a was already 10. Okay, so let me rerun this. The value of a is 10, and now I'm doing a plus equal to 3. So this is essentially like writing writing a is equal to a plus 3. The value of a was 10 and you are incrementing it by 3. So now the value of a will become 13. Now if I do a minus equal to 3, it is like saying a is now a minus 3. So now a is 13. Now you are decrementing it by 3. So now it will become 10 again. Now if you do a into equal to 3, so it is essentially like saying a is equal to a into 3, which means a is 10. Now it will become 10 into 3, which is 30. Now if you do a is equal to a by 3, or let's say a by equal to 3. So it is like saying a is equal to a by 3, which is floor division, okay, which is which is not floor division, which is the exact division. So you'll get the answer in decimal places. So now the answer will become 10.0 because a was 30 and you divided it by 3, so you'll get 10.0. Now if you do a by equal to 3, a by equal to 3. So what will happen? So here see, initially a was not an integer. Let's make again a an integer, and if I say a by equal to 3, so what will happen? 10 by 3, and we will only take the integer part, and the integer part is 3 here, okay. And the last one is exponent, okay. So if I again do a is equal to 10, and then if I do a exponent equal to 3, so it is essentially like saying a is equal to a to the power 3. Now what is 10 to the power 3? It is 1000. So a will now become 1000, okay. So this is how you can do assignment with an arithmetic operation. Now similarly you can do bitwise operations as well. So again, let's say a is 10, and now I am saying a and equal to 3, okay. So this is the first bitwise operator. So now a will become 10 and 3. 10 and 3, the value is 2. We already know this. Now similarly, if we do for OR, a OR equal to 3. So here what will happen? A will become 10 or 3, which is now 11, okay. So a or equal to 3 means a is equal to a or 3. This is something that we have already seen. Now let's do the same thing for XOR. Okay, so now a will become 10 XOR 3, which is 9. And also you can do the same thing for the other bitwise operators, which is right shift and left shift. So let us see right shift and left shift as well. So a is equal to 10, and if I do a left shift equal to 3, then which means a will now become 10 left shift 3 times. A is already 10 and you are doing a is equal to 10 left shift 3 times, which is multiplying it by 8. So a will become 80 now. And last and final we have right shift. So now a will become 10 right shifted 3 places, which means a will now become 1. So this is how you can do assignment along with bitwise or arithmetic operators. Okay. Now coming to comparison operators, you can compare two variables using the comparison operators, or two values. So if I do 10 equal to 10, so 10 and 10 are equal, and hence you will get true. If you do 10 equal to 3, so they are not equal, so you will get false. Now similarly, if you do 10 not equal to 10, so 10 not equal to 10 is false statement because actually they are equal. But if you do 10 not equal to 3, so since they are not equal, you will get the answer as true. Okay, cool. Now this is equal to and not equal to. Now if you look at greater than, less than, greater than equal to, less than equal to, let us look at that as well. So if I write 10 greater than 3, so 10 is actually greater than 3, so you will get true. Now if you do 10 less than 3, so 10 is not less than 3, you will get false. If you write 10 is greater than or equal to 10, so if you just write 10 is greater than 10, you will get false because 10 and 10 are equal. 10 is not greater than 10. But if you write 10 is greater than equal to 10, you will get true because they are actually equal. So even if it is greater or equal, you will get true. Now if you write 10 is less than equal to 3, yes, 10 is less than equal to 3, so you will get 10 is not less than equal to 3, right? 10 is actually greater than 3, so 10 is less than equal to 3 is false. Okay. So this is how you can use the comparison operator. Pretty simple. Okay. Now final is the last is logical operator, and or not. So this is used to combine two pieces of information. So if I write let's say 10 is greater than 3 and 10 is less than 10. So here what will happen? 10 is greater than 3 is true actually, and 10 is less than 10 is false, and true and false is false. So you'll get false as the output. But instead here in the same statement, if I enter an OR, so here what will happen? 10 greater than 3 is true and 10 less than 10 is false, but true or false is true, so you'll get true. And similarly, if I do not of 10 greater than 3, so 10 is greater than 3, but I'm doing a not of that, so not of true is false, so you'll get false. So that is how you can do logical operators as well. So this was a demo on all the operators that we have seen so far. Thanks. Let's meet in the next lecture. Bye bye.